All right, so we're looking at area of a parallelogram, which is just base times height. And again, this should sound familiar, guys. Base times height or length times width. Those are areas of all parallelograms, like a rectangle, a square, right? Those are all types of parallelograms that works for the same shapes. So here's one of the key things, though. Whenever you're considering the base and the height of a parallelogram, the main thing that you got to look for is to make sure that they are perpendicular to each other, right? If I'm going to consider this my base, then I need to look at the height that is perpendicular to my base. So for example, oftentimes they might give you some extra information. Here's one we're going to be looking at in just a minute. So take a look at number 4 for a sec. You don't have to do it yet. I just want to point something out. So look at this one. So I got something here that I don't need to find the area, right? How would we find base and height of this parallelogram? Well, if 20 is my base, then 8 would be my height because it's perpendicular to my base. So whenever you're looking at base and height, they have to be perpendicular to each other. You got to ignore other numbers that don't apply to that for cases like that. So we're going to start with number 1 right here. So here's the first example that you guys could write down. So for number 1, they are asking us for the perimeter and the area. So they want perimeter and the area. So our focus is on the area. That's kind of the theme of this chapter for the most part, but they do throw in some perimeter questions as well. So whenever they ask you for that, do that too. So we're going to find area and perimeter. So let's just start with the area. One thing I always recommend when using a formula is write the formula first, and then plug in the numbers. Okay, so as far as our base and our height are concerned, you guys can already see the perpendicular lines in there. So this would obviously have to be our height. So we got that 16 for height. What's our base? 18, right? Good. We got to add those together, right? The entire base is 18. So they did break up that one into pieces, but we can combine them. So if we just multiply those guys together, then we'll get our area. So as far as the perimeter goes, and we may not do perimeter on every single question because it's a lot of the same kind of thing over and over again. You guys remember perimeter, where you add up all the sides, right? Perimeter. So if we can identify all the sides, then we can find our perimeter that way. So we already know the bottom is 18. So one of the things we learned on Monday is that if in a parallelogram, if the bottom is 18, so is the top, right? So top has to be 18 as well. What about the left and the right side though? How do we get those guys? Well, you guys see that little right triangle here, right? This is why they split the base up. So if you see this, as the legs are 8 and 16, we can do a little Pythagorean theorem to get the left side of this parallelogram. So let's just set that up so you have one for your notes. Guys, notice on this one does say round to the nearest tenth. So that's at least one of the good news on this is you don't necessarily have to work with radicals. If they say round to the nearest tenth, then we'll round to the nearest tenth. So when I add those guys together, I get 320. And then to get C, I got a square root. And so we're going to get about 17.9 for the left side of that shape. And like we already talked about, if the left side is 17.9, so is the right side. So now it's just as far as finding the perimeter. All we got to do is add all 4 sides together, right? So it would look something like this. So I got the top and the bottom. And then I have the left and the right. So we get a perimeter at about 71.8. All right, so guys, that's gonna be pretty typical for these. If you have to find a missing piece, probably working with right triangles. Could be Pythagorean theorem, could be a 30-60-90 or a 45-45-90. So some of those are gonna pop up as well. So let's keep moving through. So let's look at number 2 together. Let's just start with the area. So we're gonna do base times height to get the area. So again, set this one up with me. Guys, I'll tell you, if you really write a formula down every time you use it, you'll remember it without even trying. It's a great way of memorizing formulas, is just to write them whenever you use them. And it'll be automatic at some point. You won't even have to think about what it is anymore. So let's see, what's our base and our height on this guy? One of them seems pretty clear. So we're looking at our base right here of 24. So we can go ahead and put that in. So, but you can see on this one, they did not tell us the height, right? This dotted line has to be the height because it is perpendicular to the base. Hopefully this angle stands out to you at this point. As soon as you see a 30 or a 60 or a 45, those should jump out at you right away. One of the things that we talked about on Monday was when you have a parallelogram, opposite angles are equal as well. So if that's 60, and so is this. And so as I look at the left side of the shape, you guys can see we're looking at a 30, 60, 90 triangle. So what do we know from that triangle? We have to know at least one of those pieces. Well, you guys see the congruent marks, right? Remember, those marks tell you that you have congruent sides. So if this is 24, then so is this. All right, see if you guys can see if we can work our way through a 30, 60, 90 triangle here. Yeah, go.
That's 24. Isn't all sides 24?
They,
And just know the answer.
so they are all 24 on this, but what is this? So for perimeter, yes, they're all 24, and that's easy to just do 24 times 4. But we still don't know the height yet. So let's remember our process on 30, 60, 90s. This is our hypotenuse. This guy right here would be the short leg, and this guy right here would be the long leg. So how do we go from hypotenuse to short leg? So don't think trig functions yet, just think your 30, 60, 90 patterns. Divide by 2. Divide by 2. So if you did 24 divided by 2, you get the short leg. How do we go from short leg to long leg? You're close. Square root 3. And again, guys, I did put these patterns on the last page of your notes, so if you ever need to look back on those, they're back there for you. So our height is 12 radical 3. And now we can do our base times height. So guys, again, for this one, it does say round to the nearest tenth, so we're allowed to go to the calculator for this. If it asks us to round it, would come out looking something like this. So about 498.8. So when you look at your 30, 60, 90s, the guy across from 30 is always the short leg, and the guy across from 60 is always your long leg. So the relationship that we first have to look at is that short leg, which is always half of your hypotenuse. Yep. So look at it as which one is across from 30 and which one is across from 60. All right, so 498.8 on that one. All right, so how about perimeter? So we know all 4 sides are 24. So guys, think a little logically here for just a second. Instead of doing 24 plus 24 plus 24 plus 24, what would be the easier way of looking at that? Yeah, just 24 times 4, right? So let's keep it as efficient as we can. So if all 4 sides are the same, like when you have a square, the best way to look at perimeter is simply 4 times your side length. So that's the best way to see perimeter when all 4 sides are equal. $96, I believe. Hey, you guys, do me a favor. If you do have a question out there, don't put it in the chat because I'm not seeing the chat at the same time that I'm doing this. So you just need to speak out if you have a question. Guys, take a look at number 3. I want you to work ahead of me on this one. So we're going to find the perimeter and the area. Guys, when you look at number 3, obviously all 4 sides are equal and we have right angles. What kind of a shape would it have to be if it's right angles with all 4 sides are equal? It's got to be a square, right? So squares are simply a type of parallelogram, right? Parallelogram is kind of a broad category and there's multiple types of parallelograms. A square is one of them. So we can still do base times height to get the area, which in this case, if it's a square, your base and height are equal. So it's really 1.6 times itself. So you could write that as 1.6 squared if you want. So that's what it would be if we did it exactly, not rounded. That's what it would be. Guys, do notice the directions say round if necessary. Really not necessary to round on this because this is an exact answer. It's not a rounded answer. Perimeter we could approach just like we did this one, right? If all 4 sides are equal, then why not just say it's 4 times 1.6? What is it? 6.4.
Do we need to put the units?
You know, units are nice to have. I don't like mark you down if you don't put the units. It is worth knowing that when you're finding perimeter, well, for perimeter, it's just the regular units, but yeah, you're right. If it's area, then it is the unit squared. So that's kind of the difference between perimeter and area. It's like a length versus an area. Guys, again, if I go too fast or if you have questions, just need to speak out and let me know. It's tough doing this when I only see 5 people. I don't know how the rest of you guys also are doing, so just let me know. All right, so let's go after number 4, guys. On number 4, the area is the simple part for sure, because they're just giving you a base and height, right? But what I wanted you guys to see on this, and I mentioned this at the beginning, is make sure when you identify base and height that you're identifying the correct 2 numbers. Remember, they have to be perpendicular to each other. And I will get students that will say the area is 20 times 10, even though the 10 is not perpendicular to 20. So you got to be careful on that. Make sure that you're picking perpendicular lengths. So the 20 and the 8 are perpendicular to each other. So that's why they would be our base and our height. It's got to be 160. Guys, as far as the perimeter goes, just wanted to remind you of our parallelogram properties. Yeah, we know opposite sides are equal. So if the bottom is 20, the top is 20. If the left is 10, the right is 10. Then you could add them all together. Yeah, you didn't have to do a whole lot of side work on this one. So 60 total if we add those up. All right, last one of these, and then we're gonna do a quick look at triangles. I mean, I think so, but I don't know. We might be alone on that. So, so guys, looking at number 5. Again, obviously, we know the base is 30, but we're gonna have to solve for that height. So, in this case, they're giving us an angle that should stand out to you. Let me just set it up before we start plugging in numbers. So, base and height. Again, I always recommend writing formulas down every time you use them. Great way to memorize. So I think we can clearly see that base is 30, but we're gonna have to do a little solving for that dotted line for height. Guys, real similar to one that we did on number 2, right? We know opposite angles are equal. So if that's 45, then so is this. So we are definitely looking at a 45, 45, 90 pattern. So I'm gonna give you a second to go ahead of me, see if you can figure out what this height is based on your 45, 45, 90 patterns. And you can always look at the last page of notes if you don't remember. But don't say it out loud yet. Jackson, how do we do it?
We did square root of 2.
So are we multiplying or dividing by the square root of 2?
Multiply, right?
Divide. There you go. So remember, when you're going from the hypotenuse to a leg, you're going to something smaller, right? The hypotenuse is the largest side of a triangle. So if you're ever starting with the hypotenuse, we're always going to divide to find something smaller. So we are going to divide by the square root of 2, which, guys, for this, again, because these directions say round to the nearest tenth, you don't have to keep this like in simplest radical form if the directions don't specifically tell you to do that. So it is okay to just throw this into our calculator at this point and work with the decimal, unless we're directed to do otherwise. Oops. Oh no, I was right. So here's what it would look like in the calculator. What's up, Dave?
It's 15.2, right? Is it because it's 45, 45, 90? Or is it
Because it's 45, 45, 90. Yep.
and if it's 3, 60, 90, it's the 3, right?
Yes.
So what would I put for height? Square root of 2?
Well, it's 15 divided by the square root of 2
Oh.
is your height.
Can you put it as a decimal? or-
You certainly could put it as a decimal. One thing I try to avoid is I try to avoid rounding in the middle of a problem, right? So, because if I start to round numbers in the middle and then I start combining those rounded numbers, my ending result could be a little bit off. So I as much as possible, I try not to round till the end. I try to keep things exact as long as I can. Guys, obviously for perimeter on this, it would be the same as what we've already talked about. So I'm going to jump ahead and keep moving forward. But in your assignment, if it does ask for perimeter, I do want you to do that. So guys, let me just mention something real quick before we get into triangles. 2 things. One is, and some of you guys probably already know this if you don't look ahead, what's the area of a triangle?
It's half of the base on height.
Yeah, it's like the same formula, but with a half thrown in, right? It's half base times height simply because if you look at a parallelogram, a triangle is half of a parallelogram. So it's base times height divided by 2 because it is half of a parallelogram. One of the things I wanted to mention on this is sometimes with an obtuse triangle like this one, they may draw the height on the outside of the shape. What I want you to know about this though is you see how these lines are dotted? If you see dotted lines, then that is not part of the shape. It's only there to give you information, right? It's not part of the drawing. So on this one, if I said, what's your base and what's your height, would our base be 11 or would our base be 13?
13.
So
So remember on this, if you see dotted lines, it's not part of the shape.
Okay, so
Right.
what is it?
Yeah, so it would just be 11.
And then the height would be 7, right?
Well, what's perpendicular to 11?
6, 7.
Right. So this would be my height. This would be my base. So again, guys, when you see these dotted lines, the dotted lines that mean it's not part of the shape, but one way or another, they're trying to give you information. Okay. And so it's there to provide information like a height, but we're not using a number like 2 as part of our base. It's only there to help give you information. So we'll practice some of that right now. But if you are going to keep track of your formulas, like I hope you will, add this one to the last page of your notes where you have your list of formulas. So it should be the next one on the list.
That makes sense.
So sometimes on this shape, you'll see the height can be drawn inside the shape, like it is on this one or like it is on this one. But sometimes they'll draw the height on the outside of the shape, like you're going to see in a minute here on number 2. Okay, and so just recognize what you're really looking for is where are the perpendicular lines, because those are going to act as your base and your height. So we're going to jump down to these guys. So what I did on the 3 that you're looking at, I really tried to darken in the triangle. Okay, the dotted lines again are there to provide information, but they're not actually part of the shape itself. They're just there to give us some extra information. So if you look at number 1, again, I would encourage you to start with just writing the formula. So it's a triangle, so we're doing 1/2 base times height. And then we're going to fill those in as we find them. So again, guys, just to make sure this is clear, is our base 15 or is our base 18?
15.
It's 15, right? Because remember that 3, if it's on a dotted line, doesn't count as part of the base. Okay, so our base would just be 15 on that. So then the height must be perpendicular to that base. Did they give us the height on this one?
No.
Yeah, they did. 5.
Is that 5 perpendicular to your base?
Pythagorean theorem.
Good old Pythagorean theorem. However, there's a shortcut on this one. You might remember certain Pythagorean triples that always go together. We had one called a 3, 4, 5 right triangle. Guys, you could certainly use Pythagorean theorem. Okay, you could say a squared plus 3 squared equals 5 squared, and you could solve for this, no problem. But you might remember some shortcuts, like we had Pythagorean triples. One of them was a 3, 4, 5 right triangle. So we do know that our height is going to be 4. Whether you use Pythagorean theorem or just your knowledge of a triple, we can get that height. What's up, Dave?
I would use Pythagorean theorem. What numbers would you use?
So I would use these guys right here. So if you use Pythagorean theorem, your setup would look something like this. So that would be our setup if we were going to go that route. If you solve for it, you should still end up with 4.
When you're putting Pythagorean theorem together, it doesn't matter what order you put A and B.
No.
No.
Yeah, no, because it's addition, either one of these guys could be A, the other could be B. Doesn't matter which one's which. As long as you get your C value correct, we should be in good shape. All right, guys, so let's finish this one off. So if we calculate that, we get an area of 30. If we were asked to find a perimeter, guys, again, keep in mind, as far as the perimeter goes, it's the 15, it's the 4, and it's whatever this is, right? So keep that in mind, right? We're not looking at these numbers as part of our perimeter. It's the perimeter of the gray shaded triangle, okay? And so even on this part, if you were going to do this, and we won't do this for every single one, but let's at least do it for one of them so you have it for your notes. So if we're going to do the perimeter, we already know the 15 on bottom. We know the 4 on the right side. what are we going to do to get this guy? Good old Pythagorean theorem. You guys can be experts at this. So, right. So, yeah. So I know this is 4. I know this leg is 15. We're going to use Pythagorean theorem in order to get the hypotenuse. So a lot of right triangle work, as promised. But that's the setup we would have to use in order to get this hypotenuse. We'll just throw it in real quick so we can finish this one off. And then we won't do these for the other, but I wanted you to at least see it once. So if we did our 15 squared plus 4 squared would give us this. So then we're going to square root 241. Yep. So about 15 and a half. So if we were going to complete our perimeter here, you would just have to then add the 4 and the 15 to get the total perimeter. So we used Pythagorean theorem to figure out that this was about 15.5. So again, these are the numbers that we just added together in order to get our perimeter. Guys, why don't you try the area on number 2? Let's get the area on number 2. See if you can go ahead of me on that one. This one should be pretty straightforward. So guys, really the main thing I'm hoping you recognize at this point is which numbers need to act as your base and your height. Good. Yep. Yeah, so I'm looking at the 22 as my base because it's the bottom of the triangle. And I'm looking at 16 as my height because that's the guy that is perpendicular to this base. All right. Guys, if you were going to do perimeter, and in the interest of time, I'm going to keep moving, but if you did the perimeter, it would be very similar to what we just did on the previous one, where you would have to use a little Pythagorean theorem to figure out this guy. And then you could add your 3 sides together. All right, and we'll do one last one of these. We'll do this real quick. This one's not a whole lot different. So again, on this one, guys, if we're going to do, so for this one, is this 15 at all necessary in any way?
Yeah.
Let's see. We know our base and our height, so we got the area. If I really wanted perimeter, yeah, we would just do Pythagorean theorem with the 11 and the 40 to get our 3rd side. So this is really, in this case, very much just extra information that we wouldn't need. So don't be distracted. All right, so let me just do the area portion of this, since we've already done some Pythagorean theorem on perimeter. So here's our base, here's our height. So that'd be our area. I believe it's 220.
Yeah.
Okay. Because I wanted to remind you of something. We're going to end on this. Back when we started learning about right triangles and all that Pythagorean theorem stuff, there was 2 big shapes that kept coming up over and over again. One of them was an equilateral triangle. Okay, so I wanted you to remember a couple things about an equilateral triangle. First of all, why is it called equilateral? Because all 3 sides are equal, and what else is equal? That's a good guess.
Oh, angles.
The angles. So not only are all 3 sides equal, but remember all 3 angles are equal too. if all three angles are equal and have to add to 180, what is the measure of each one? And here's a number that should jump out at you right away. Right, so this is what we want to remember about an equilateral triangle. Right, that's what that looks like. So let's look at this guy real quick here. So in this case, they're telling us that the perimeter is 12. Well, if the perimeter is 12, and yeah, all three sides are equal, what would each side have to be? Good. Oops, I said it out loud while I was thinking of something else. So we're dividing by 3 so that it becomes 4. All right, so if we take our perimeter and divide it by 3 because we have 3 equal parts, then we know this. So the one thing we don't know is our height. Let's see. So I think we could all agree that our base is 4, but our height would be right here. Guys, look at that top angle. It was 60, but when we just drew in the height, that 60 just got split, which again creates our famous 30, 60, 90 triangle. So I'm going to give you 1 minute to give this a shot real quick and see if you can figure out the height before I do. You could, because if this is 4, what is this length? It's 2. It's got to be half of this, right? So absolutely. And guys, so Jackson just mentioned if you wanted to do Pythagorean theorem, you certainly could. You could say 2 squared plus b squared equals 4 squared. And if you want to go that route, go for it. I do think a 30, 60, 90 rules are quicker. But if you want to use Pythagorean theorem, then go for it. Okay. So let me just throw in some numbers here. My hypotenuse is 4, which is why my short leg is half of that. So we know this is 2, and then from short leg to long leg, as we already talked about, we multiply by the square root of 3. So there's our little 30, 60, 90 pattern. Now we know our height. Now we could get that area. So if we round to the nearest tenth, we'd be looking at about 6.9. Guys, what I'm showing you, what I'm trying to show you with every single one of these problems is I am following a 3-step process with every single one. I start with a formula. I then show exactly which numbers are going in for each piece of that formula. And then the third line is always the answer. So these are like the 3 lines that I always recommend taking whenever you're using formulas and doing problems like this. Start with the formula, show the substitution, and then show your solution.
I got 7 in the answer. Is that okay?
Like exactly?
Yeah, because I did the Pythagorean theorem and I rounded it 3.5.
So I'm glad you said that. So that's why I don't round in the middle of the problem, is because it might affect your ending answer. You know what I mean? So if you would have done Pythagorean theorem, here's really what you would have gotten. Let's see, 4 squared minus 2 squared, so 16 minus 4 is 12, so square root of 12. So that's what you would have gotten for your height. If I use the full value, so in other words, if I multiply it, so that's your height, right? But as a decimal. I wrote mine as a radical, you wrote yours as a decimal. So if I don't round it in the middle of the problem, and I just hit times 4 times 1/2, then I'll get a much more accurate answer that way. So that's why I would always recommend try not to round in the middle of the problem because it might affect your ending result. What you could do is just round a little deeper. Like 3.5 is a pretty shallow rounding in the middle of a problem. If you would have used maybe 3.464, we probably would have still gotten both 6.9. So if you're going to round in the middle, round deeper so that your ending result is more accurate. Is there a question, Dave?
No.
So guys, let me just pause this real quick.